God bless you, Algebra 2 standard students. I think this is a practice test in which we're going to need God's help more than anything else, and I'd like you to trust Him for leading us and guiding us as we take a look at these practice questions here. And this might be a good place to start, where it says write a verse which tells you what to do with your ears in order to increase your learning and improve your grades. And I need to do the same thing as I listen to what the Lord would say to me in terms of helping you. So it says in Mark 5:23, if anyone has ears to hear, let him what? Let him hear. I'd like us to put that in practice today. Just really be listening, and I'll seek to do the same. So say it with me one time. If anyone has ears to hear, let him hear. Only 9 words for that one. So I'm going to go straight to the area of concern here, and that would be these questions. So I'm going to give you at least 2 of these questions to do. It said identify the leading coefficient. Leading coefficient. All right, let me go to this one here. Leading coefficient would be the number before the highest exponent term, which would be highest exponent is x cubed, and the number before that is the leading coefficient. It's -4. The degree, so it's going to be the highest exponent, which is 3. And here's what I'd like you to put in. Leading coefficient, I'd like you to just make a note that it's negative. Highest exponent term. And the degree, 3 is what? Odd or even? Odd. And that's going to determine the next part of it. We have a negative leading coefficient and an odd degree polynomial. So it's either going to go this way or it's going to go this way. Because odd means one is increasing at one end and decreasing at the other end. So it's going to go this way, this way, or this way. Which do you think it will be? Well, this way here would be the odd positive leading coefficient. Okay, so this is for the odd positive. So this way would be what? Odd negative. And that's what we have before us. Odd negative is this way. So listen carefully now as we do what is called the end behavior. And in essence here we're looking for what is going to happen to y when x becomes really large, either positively or negatively. So let's track here. Let's take this branch here, and this is your x-axis. So this is positive x, this is negative x. So when x becomes large and negative, going like this, track with me, large going this way, then this thing is going to keep going up and up and up and up and up. So y is going to be what? Large and positive. And that's what's called approaching positive infinity. So as x approaches negative infinity, again that means going this way, then y approaches what? positive infinity because this is a positive y direction going this way. Okay? So y, or f of x, which is y, approaches positive infinity. That's not infinity. Let me change that. That should be like more like this. Positive infinity. All right, so we're finished with this branch. Let's do this branch. Again, this is the x-axis. So when x approaches positive infinity, that means it's getting larger and larger and larger like that. What's happening with y? Y is going down, so y is approaching negative infinity. So this is the second branch. As x approaches positive infinity, f of x, or y, approaches negative infinity. So that would take care of the end behavior. And by the word end, they just mean what's going to happen at the furthest end. So for end behavior, you're looking at two things. X approaches negative infinity, what's y going to be? When x approaches positive infinity, what's y going to be? That's pretty much it. Two scenarios. X going to negative infinity and x going to positive infinity. All right. Let's do another one. And I would like you to go back and just redo these. But let's do another one, which is going to look kind of similar to this one. Similar to this one. So here it is. This one over here. 3a. First of all, leading coefficient. What is it? It's going to be the 7. The degree, third degree. But here's what I want you to write very quickly. Beside the leading coefficient, I want you to put it that it's positive. And third degree, what does that tell us? It's odd. And odd is when they're going in opposite directions. So we have a positive, odd polynomial. Remember I told you over here when positive and odd will look like this. So over here beside this one, I'm going to help myself to remember by saying this is going to go this way on the left end, and at the right end it's going to go like this. That's going to help me. Again, this is the x-axis. Y-axis is like this. So when x approaches negative infinity, then this is what's going to happen. What is the y doing? The y is going down, so the y is approaching negative infinity. So again, x approaches negative infinity going here. The function is going down like this. So as x approaches negative infinity, f of x, or the y, is going down, so it is also approaching negative infinity, like so. We only do two scenarios. We're going to look at x now as it approaches, as x approaches positive infinity. So which way is that? Well, let's take the right branch. This is positive x, so x becomes positive and large. Look at the arc here. It's become positive and large as well. So that means y, which is f of x, will approach positive infinity. Okay? So those are the two scenarios. Again, we just look at x as it approaches negative infinity. What happens to y? And then we look at x as it approaches positive infinity and find what happens to y there. So you go ahead and do this one. This one is even degree and positive. So just to review with you quickly, even positive would go like this. even degree like 2, 4, 6, 8, and negative leading coefficient would look like this. Okay, so that would give you a little bit of a cute clue, but you do all of it. You do the coefficient, leading coefficient, do the degree, and so on for this one. All right, I want to do this down here with you, some of these. It says write a rule for each of the function and sketch the graph. It's f of x equals x cubed minus 3. So let's take a look at a few of these together. I'm going to go to the other page. Here we are given f of x is equal to x cubed minus 3. Let's take a look at what this graph looks like. The parent function f of x equals x cubed would look like this. That's what the cubic looks like. And you'll remember from the previous question that it goes like this when the leading coefficient is positive. So this is odd. And leading coefficient of positive. So f of x equals x cubed would look like that. What would f of x equals x cubed minus 3 look like? It's the same thing, except we translate down vertically 3 units. So it'd be 1, 2, 3. So I'm going to make this solid now so we can have it more permanently here. This is what we're looking at here. That's the original. All right. Now, this is what we're originally given. They ask us to find g of x, which is a transformation of that. So g of x is equal to whatever f of x is plus 6. So all we do is we take the original and we add 6 to it. So graphically it would look like this from here. 1, 2, 3, 4, 5, 6. Like that. This would be the given f of x plus 6. And in terms of the algebra, you take a look at this f of x plus 6. What's f of x? F of x is x cubed minus 3. So you write x cubed minus 3, and then you add 6 to it. So negative 3 plus 6 gives me positive 3. So that's what the g of x would be like. That would be the rule for the g of x. Let's go ahead and take a look at another one. H of x is equal to f of x minus 2. What would that look like? So here we have h of x is equal to whatever f of x is minus 2. And let's see what this would be. Well, we come back to the f function, and wherever we see x, we put what? X minus 2. So let's go ahead and do it. H of x is going to be, wherever we see x, we're going to put x minus 2. So in here, we're going to put x minus 2, and that's going to be cubed minus 3. So what does that look like? Well, here's what it looks like. We take the original function and we move it forward 2 units. That's what this x minus 2 is. If there were a plus, then we move it back 2 units. So here it is, original, we move it forward by 2 units. 1, 2. So it will look like this.